Okay, so we've got another advanced mechanics question here. We are given a picture of a trajectory and we are told to find the initial velocity. So we have quite a lot of information in this graph. We don't know how high the thing goes because we're not given any information on the y-axis. We do know that it travels 120 meters along the x-axis though. We do know the launch angle is 75. Well, in our last question we established that the x maximum is actually equal to -2 times the initial velocity squared times sine of theta times cosine of theta divided by gravity, g, where g is -9.8. So we can actually use this in order to find the initial velocity, because the u is the initial velocity we're after. It's the only thing we don't know. We know gravity, we know the thetas, we know the x max, so we can rearrange this and plug everything in. So first, I'm going to make both numerator and denominator positive, and I'm going to let g be 9.8. I am going to multiply both sides by 9.8. This gives me 9.8 x max is equal to 2 u squared sine theta cosine theta. Divide both sides by 2 sine theta cosine theta. Divide this by 2 sine theta cosine theta, and take the square root of this result will give me u is equal to positive negative square root of 9.8 times x max divided by 2 times sine of theta cosine of theta. Now in this case it's going to be positive, so we can actually ignore this positive negative. Whenever we do a square root, it's good to identify positive and negative. This is going to be our formula. So now let's plug everything in and get our initial velocity. So we have u is the square root of 9.8 times x max, which we can see from the graph is 120, that's this value down here, over 2 times sine of 75 times cosine of 75. So this, if we plug all this into our calculator, we get square root 9.8 times 120 over 2 times sine of 75 times cosine of 75. I get 48.4974. 0.497 dot 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 keeps going. So if we round this, we find that the initial velocity was about 48.50 to 2 decimal places meters per second. And this is the answer that we're after here. This was a nice quick way to do this. Using these shorthand formulas for positions, velocities, initial velocities, trajectories, or things like that can be quite helpful. They can speed up a question that would otherwise take a lot of working into just a few steps. So here we only had a relatively small number of steps, but we're able to get the correct answer regardless.